Good day, everyone. We are doing this as an assignment for our deep learning module. We are training four supervised learning models using deep learning for brain tumor prediction. This is the content of our presentation. First, the introduction. Brain tumors represent a small fraction of cancers, accounting for only 2%, yet they significantly contribute to cancer-related deaths. Therefore, early detection is crucial. Traditional diagnostic methods such as MRI and CT scans often rely on subjective interpretation, which can lead to inconsistent diagnosis. Deep learning can automatically identify tumor features in medical images, enhancing diagnostic accuracy. Despite these advancements, challenges remain, including data variability, overfitting, and the need for substantial computational resources. Looking ahead, we aim to develop improved models and techniques to enhance brain tumor detection and patient care. Then, the overview of the dataset we used. We utilized the brain tumor classification dataset from Kaggle, which includes MRI images for detecting and classifying various brain tumors, benign, malignant, and pituitary. This dataset contains a large volume of complex image data, which need the advanced deep learning algorithms to manage the variability in tumor size, location, and characteristics. Then I'm going to give a brief explanation about the model I built using convolutional neural network. First, data preprocessing. The data preprocessing steps included resizing all images to 150 by 150 pixels to standardize input dimensions. I shuffled the training data using a fixed random state to ensure consistency and prevent bias. The dataset was split so that 90% was used for training and 10% for testing, utilizing train test split to maintain randomization. Class labels were one-hot and encoded for multi-class classification, and images were normalized to range of 0 to 1 to facilitate faster convergence during training. Then the model selection. The architecture of my model consists of 16 layers, including 7 convolutional layers, 4 max pooling layers, 5 dropout layers, and 2 fully connected layers. The convolutional layer utilizes ReLU activation functions, and a 30% dropout rate is applied to prevent overfitting. The output layer consists 4 neurons corresponding to the number of tumor classes, with a softmax activation function for multi-class classification. I used NATM optimizer and set the learning rate to 0.02. This is regarding model training. I used NATM optimizer and set the learning rate to 0.02. The loss function used was categorical cross entropy, suitable for multi-class classification task, and the model was trained for 30 epochs with a batch size of 32. Accuracy was measured as the key performance metrics throughout the training process. Then, this is the final result of my model. The final training accuracy is 0.92 and the final training loss is 0.2. Final validation accuracy is 0.89 and the final validation loss is 0.3. Thank you.
Hello everyone. In this assignment, I used CNN model with VGG16 backbone to train this model to predict the brain tumor classification. In this model, uh, I resized image to 150 by 150 pixel to standardize the input dimensions. Also, I shuffled the data fixed random state with 42. To the train the model, I have used 90% of data set from the total data. Also other 10% were used for testing. I encoded the label with one hot encoded method. In the model we have 16 total of layers, including 7 convolution layers, 4 max pooling layers, 4 5 dropout layers, and 2 fully connected layers. I use ReLU activation for activation function and dropout rate for 30%. In the validation, accuracy were 95% and the loss were 0.2 likewise. For other model, I used masked RCNN for the train the model. For the data pre-processing task, the all images were resized to 150 by 150 pixels to standardize the input dimensions. For the shuffling data, I used random state 42. To the testing purpose, I have used 10% of data amount, and the training for the model I have used 90% of data. Data label encoding, I used one hot encoded for the compatibility with masked RCNN architecture. Masked CNN model has a total of 16 layers, including 7 convolution layers, 4 max pooling layers, and 5 dropout layers. A dropout rate were 30% for regularization. The model accuracy was 70% and lost were 0.5 likewise. Thank you.
In this video, I'm going to give a brief explanation about the model that I built using ResNet 50. Data reprocessing. As the initial step of data reprocessing, all the images should resize to 224 by 224 to match the input size of ResNet 50 model. After that, the resized training data was shuffled by a random state equal to 42. The purpose of it is to maintain consistency. In the train test split, the flow from directory method automatically shuffles the data at the default training duration. In the label encoding step, all the training data were labeled by one hot vector encoding method to categorize for all multi-class classification. In the normalization method, all the image pixels values are rescaled between the range of 0 and 1 by dividing 255. It helps to improve model training efficiency. Model selection. The architecture of my model consists 59 layers. In these 59 layers, there are 50 convolutional layers. These 50 convolutional layers are the default layers of ResNet 50 model, and 2 max pooling layers, 3 dropout layers, and 4 fully connected layers. In the 50 convolutional layers, from with the base model for ResNet model, there are 3 by 3 kernel and ReLU activation. In the pooling layers, there are 2 max pooling layers. Actually, the global average pooling 2D is applied after certain convolutional layers for downsampling. There are 3 dropout layers with 50%, 40%, and 30% dropout applied to several stages for regulations and preventing the outfitting. There are 4 dense layers of 512, 256, 128, and 64 neurons for each layer with ReLU activation. And the last layer, the output layer, it has 4 neurons for the matching the number of classes with softmax activation flow classification. Model training. The optimizer that I used is adaptive moment estimation. The learning rate of learning rate of my model is 0.0001, and the loss function, categorical cross entropy, is the loss function for multi-class classification. Is the suitable loss function for the multi-class classification. The accuracy measured as the key performance metric. I have used 20 epochs for train, and the batch size is 32. This is the final model result of my model. The final training accuracy is 0.3921, and the final training loss is 1.2364, and the final validation accuracy is 0.2665, and validation loss is 1.6722. Thank you.